So my name is Alex Stamos. I am also a capitalist. I'm a co-founder and partner at a company called iSEC Partners up in San Francisco with offices in Seattle and New York. And I'm here to talk about cloud computing. Don't run, because it's not a standard cloud talk, I hope. And I'm sorry I'm using the term cloud. I tried to resist it for a couple of years, but it's impossible to not use the term cloud computing anymore on a day-to-day basis. So our talk today is about what to do from a infrastructure and architecture perspective when you're designing a enterprise web stack in the cloud, what things change, what things stay the same, and some of the solutions that we have found in our work that we have done with clients who have moved high security, high availability systems up into usually infrastructure as a service providers, and some of the things that need to be done. And I think there's a lot of interesting research and product opportunities here. So if there's any venture capitalists or entrepreneurs in the audience, I think there's a couple of things here that would be great for you to go get Series A and try to do, because there's a lot of opportunity and a lot of unsolved problems. So I asked for not to do my bio, but I started iSEC 6 years ago. Before that, I was with a little company called AppSec. Where's the shout, Katie? We have the little AppSec mafia usually at conferences like this. Before that, was a company called LoudCloud, which was cloud computing before it was either trendy or profitable. And we're mostly famous as the company that ended the first .com boom. But also kind of demonstrated, there was a big need around around 1999, 2000, for people to have much more efficient ways of doing web hosting and managed hosting. And before the advent of widespread x86 virtualization technologies and a lot of the other kind of glue technologies that we have now, that was a much more difficult thing. LoudCloud actually did cloud computing by people physically taking sunboxes, putting them into a rack where you'd pixie boot them onto an OS image that was customized, and then push packages on it, and then physically taking that box and moving it to another rack. Which, obviously going on EC2 and pushing a couple buttons is a little easier and has, less of a chance of an injury. So anyway, the takeaways today. Things you should think about while we do this talk. In my opinion, a lot of the current conventional wisdom on cloud computing is missing the point. And I don't want to insult anybody who's worked very hard on the Cloud Security Alliance and the other types of big vendor-driven cloud computing groups, but I think a lot of their concerns are actually missing the point based upon our work in forensics and incident response on actual cloud infrastructures, and I'll talk about that in details. If you aren't rewriting your software, it's not really cloud computing. That's something I've been saying for a couple of years. If you take Microsoft Exchange and you pop it onto a Windows instance at Amazon, you're not doing cloud computing, right? You're doing enterprise virtualization. Now, if you take Exchange and you rewrite it so it uses a distributed database system on a distributed file system using locally attached storage, and it had the ability to scale tiers and to have tiers loosely coupled, and so you could have the mailbox tier versus the front end tier versus the OWA tier, and all those things could be dynamically scaled based upon load, then that would be cloud computing. But just taking something and putting it in the cloud is not really cloud computing. If you're not rewriting your software, you're not using it, and certainly you're not getting some of the security benefits you can get out of the cloud. Secure cloud computing applications are basically about collapsing the perimeter, about redefining how we define the perimeter in our infrastructure and collapsing it down to the smallest unit. That might be actually a class or a servlet. It could be something as large as a virtual machine or a virtual instance. But it's all about collapsing the perimeter much smaller than the units that we had control of in the past, like a unit of a data center or a VLAN. And if you go through this process, we found going through this process with clients that they can actually end up much more secure than before, that a lot of standard web application vulnerabilities and standard mistakes that people make, if you go through the process of rewriting your app for the cloud, think about security from the beginning, you should end up in better shape than when you were self-hosted in your own rack. Okay, so what's the conventional wisdom I was talking about that I think is missing the point? So the best works to read about this would be the work of the Cloud Security Alliance and the thing called the ENISA Cloud Computing Report. Who's read either of these documents? Okay, you're lying. You skimmed them. You didn't read either of them, especially the ENISA report. ENISA is kind of a civilian NSA for the EU. It's an organization that puts together guides and goals and hardening guides and not really standards, but guidance for civilian groups in the EU about how they should do security. Cloud Security Alliance is obviously, there's a couple of famous members who are speaking here, mostly vendor-driven, mostly driven by security vendors, which is interesting because a lot of the kind of conventional wisdom that comes out of the CSA happens to suggest that you buy things like Symantec products and such, which is not shocking since those are the kinds of folks who are sponsoring it. A lot of the focus on this kind of things, especially the ENISA report, a lot of the focus is on multi-tenant risk, is on the use of multi-tenant technologies in the cloud, virtualization layers, multiple tenant databases where you have kind of nebulous security access controls between different clients. For example, Amazon DB would be a generic non-SQL based a key value pair based database where they don't really document what access controls exist between the different tenants of Amazon. Focus on shared networks. A lot of focus on denial of service attacks against other people in the same network and how you protect yourself. And I think those are some reasonable concerns, right? These technologies are not very well tested or developed. We're really in the infant stage of a lot of these technologies. But realistically, from what we've seen, those aren't actually the risks people who are in the cloud right now are facing, right? I've never, of all the companies we've done IR on where they have cloud computing, it's never been because somebody used cloud cartography to move an instance next to them onto an Amazon droplet. Droplets are what they call their servers, and then used a Zen ODay to take over execution of the Zen hypervisor, and then jumped into the memory space of the other cloud, right? That's never happened as far as I know. And if that does happen a couple of times, then that bug will be found and fixed and patched. That's kind of like saying the big problem with using Office suites is, MS 08-043, right? That specific bug is not an issue and does not indicate really where the risk is here. What are some of the realistic threats to cloud computing? Absolutely the most often threat that we've actually seen is the loss of credentials via attacks against individual admins. One of the big problems of cloud computing is it creates a class of user that never existed before. It creates a class of person that via a remote electronic authentication, usually just something like a shared secret, like a password or the big little, the big key that Amazon gives you, the secret key to authenticate yourself against their web services, that you've created the remote version of somebody who can physically walk into your data center, right? Physically walking into somebody's data center used to mean risking getting arrested and risking dealing with these ex-cops who, while they don't look like much, the data center guards are really itching for some action since they retired from the force and would be happy to apply the beatdown if they caught you sneaking in the back door. And the creation of this user account has led to much easier ways to get full access to somebody's infrastructure. In an EC2 instance, and I'm going to use EC2 just because it's what most people are familiar with. Obviously, these issues exist with all the infrastructures of service providers, more or less. You can do things like get your list of machines, be able to turn off and on arbitrary machines once you get this user account, access any persistent storage. Now, it's much harder to access non-persistent storage, which is an interesting issue. And there's no really good way of accessing in-memory storage, which is interesting. And then access the consoles of these machines, although not the SSH keys. Like I said, there are some things that are still secure, and this is the kind of thing you need to think about when you think of this attack. Where are the places that you can put secret stuff? In-memory running machine state is the kind of thing that, unlike when somebody is physically at your machine, there's no easy way to get that. There's no cold boot attack against an EC2 instance using a remote key. Logging credentials and the non-persistent storage, the hard drives that are normally attached to non-EBS-backed EC2 instances, for example, are not easily retrievable via any mechanism other than logging in and DDing those drives, which also turns out to be a big pain when you're trying to do forensics on those machines, it turns out, because there's no way of getting that image. The next most often problem that we see is operational security breakdown. How many people would you have to hire if you got a startup and you wanted 1,000 machines, right? Let's say you wanted to recreate a small Twitter, and you go out and you get venture capital, and you're going to host it yourself. How many sysadmins do you need to unpack 1,000 Dell boxes, rack and pixie boot 1,000 servers? Anybody who's done actual operational stuff, anybody want to answer how many people you'd hire? Maybe on a temporary basis. 10, 15? 25? Yeah, I mean, if you wanted to do it in less than 6 months, right? You need a decent little army of part-time sysadmins to just get that done. That's also something you can do in a couple of days with a credit card on Amazon, right? You create your Amazon account, you call them up, you tell them you want 1,000 instances, you sign a couple of contracts to get over that 50 user limit, and then all of a sudden you're able to boot that up within a couple of hours. And the fact that people are now able to bootstrap themselves with a much smaller operational staff than they used to is leading to a lot of operational breakdown of not the cloud side, but of the actual instances themselves. People aren't planning ahead. How are you going to patch those 1,000 machines? And you might think this sounds kind of silly because people should do this, but honestly, we've dealt with, things like some of the largest social networking companies on the planet where they've moved from physical to virtual infrastructure, and they did so within a 1-month period. And after doing so, realized that they had just created 3,000 instances that they had no way to patch, right? Except SSHing into them individually and doing apt-get. Right? And so that is a major, major problem when people move into the cloud is they don't think ahead of time of the benefits you get from the cloud. I mean, some of these benefits that you can get from using a cloud computing environment is some of these things don't actually have to be done, can only be done once, right? If you build your cloud environment correctly, then you should be able to have your web tier. If you want to patch your web tier, you patch a base image and then boot up 50 of that base image, change your load balancer settings to move all of your load or migrate your elastic IPs over to those machines so they take the load and then kill the unpatched machines, right? There are very different ways of doing some of these operational things in a cloud computing environment that people don't think ahead of time. And what they end up is 2,000 or 3,000 unmanageable machines, and they only have 2 sysadmins because it only took 2 guys to go on the Amazon console and click enough buttons or using the Firefox plugin, the EC2 Fox. This is less of an issue for people who are starting the cloud and more of an issue for people that do a direct port to the cloud that say, I want to move into the cloud, I'm tired, and usually because they have a very hard financial deadline, they don't have the time to plan ahead. And then the third issue is kind of the misuse of new cloud technologies that most admins and operational people and network people don't really know how to use the security technologies built in here. For example, how do you do access control in Hadoop? Turns out you really can't, actually. You can do a Kerberos front end for Hadoop that will have people authenticate, but once folks are in Hadoop, there's almost no access control between different data sets that are loaded up into a Hadoop instance, right? That's not something that's very well understood, and when people architect these systems, they assume that these new cloud-enabled systems will have the same security and isolation benefits that they got out of MySQL or Postgres or Oracle or any of the non-cloudified technologies, and they actually don't. For one of my colleagues gave a talk at Black Hat actually all about Hadoop security and how half-assed it is, basically. I mean, they have a big project to retrofit security on Hadoop, and we really could not come up with a situation where it actually provides a security benefit. So this is a real one. One of the real problems that cloud computing environments have is cloud computing vendors, I guess, assume that you'll never fire somebody. And we're in the middle of a legal process right now based upon the fact if you fire somebody and they walk away with their Amazon key, they have the ability to destroy your entire company. And that's something, the operational, like day-to-day, how do I control which of my admins have what power? How do I revoke that power? Those kinds of things actually don't line up very well with operational security. I mean, you'll see I never said hypervisor bugs in here, because honestly, again, that's not a problem that we've actually seen on an incident response. Some concerns, while I said the hypervisor issues are reasonable concerns, just not as realistic right now, the concerns I think that are really silly, physical data center security and side channel attacks. The physical data security, we have a lot of people who say, oh, well, I can't move up in the cloud because, Amazon won't, they gave me the SAS 70, but they won't let me do a physical data center inspection. The physical security of the data centers for the major cloud providers, unless you are a government agency or you're a regulated industry in a dedicated data center that you own yourself, almost certainly the physical security is much better. I have seen the inside of these data centers. There's no partitions on the inside of the data centers. Why? Because they're not multi-tenant. If you want to talk about bad multi-tenant technologies, how about cyclone fences that go up 8 feet when there's a 12-foot ceiling in your data center, right? That's a crappy multi-tenant technology where because of fire code, they're not actually allowed to give you a cage that's lockable. Or really bad physical locks that can be easily lock-picked on individual racks in the data center, individual cabinets, right? For the vast majority of people that do not own their own data center, the physical security of these data centers is much, much better. And then side channel attacks. I mean, there's been lots of academic research about side channel attacks in hypervisor environments. For most of the useful side channel attacks that you can do are actually doable remotely. they have very little to do of pulling data directly out of the local CPU. A lot of like the network and timing attacks and such. Anybody here know who Nate Lawson is? Right? So I strongly recommend going back once Black Hat posts it and watching his Black Hat talk about what kind of timing attacks you can do against things like HMAX and compares